Hi, my name is Jens, and I'm going to introduce you to our Bachelor Education in Chemical Engineering and Biotechnology. The take-home message of this presentation actually is already seen here from the first slide. The Chemical Engineering and Biotechnology Bachelor is a very broad education. It teaches you to use your math, chemistry, physics, biology, and engineering creativity that you have learned through high school in order to improve the world around you. In this way, it really enables you to contribute directly to the green and sustainable transition of society, which really is needed in these days. As I said, it's a very broad education. It provides work opportunities in many different areas. You can get to work with new materials, you can work within the energy sector, you can work with production of medicine, protect the environment, producing foodstuff, and you can work with nanotechnology. And just to put a few illustrations on what I just said, then this is an example where we produce new compounds from sustainable biomass sources using advanced biotechnology. You can also work on removing pesticides from groundwater in order to produce clean drinking water, and you can be part in development of new materials and processes for production of sustainable energy. But I also brought some other examples on how engineers in chemistry and biotechnology contribute to society. It is engineers like us who provide the world with energy. We are an important part of providing fuel for the transportation, for cars, trucks, buses, trains, etc. We provide fuels for heating of houses, of buildings. We provide fuels for electricity production. But it's also us who make sure that the utilization of natural resources goes on in a sustainable way. We also make the energy production more sustainable. We reduce the emission from carbon fuels, from fossil fuels. We capture carbon dioxide so it's not emitted to the atmosphere. We produce new materials for solar panels, for solar cells. We produce new composite materials for windmill turbines. We produce fuel cells, and we utilize the power of electrochemistry in order to generate electricity out of chemical reagents. Electrochemistry is also the backbone in batteries, which can be used for energy storage and in order to transport energy. And we also develop new type of energy production. It can be from geothermal energy, or it can be in the way of osmotic energy production. It's also engineers within chemistry and environment that protects the environment. We develop new materials, new products which are more environmentally friendly and are more biodegradable. We also clean up if the damage has already happened, and we can remediate contaminated sites for pollution. We also develop processes for treatment of air, water, and soil. And as I said before, we are able to develop carbon capture processes which mitigate climate change and the global warming. We also develop technologies in order to reuse waste materials, degrade waste, and reuse it into new materials and new products. And in this way, we protect our general resources on Earth. We are also part of curing diseases and extending lifetimes. Engineers like us produce pharmaceuticals, some of it through advanced biotechnological production platforms. We are also part of developing new instruments and medical devices that can make a difference on hospitals and for patients all over the world. And then we also develop new active ingredients and take it from the lab and out into a large-scale production so that it can actually come to the benefit of all humans on Earth. A very good example of that is the vaccines which are right now being distributed around the world for curing the COVID-19 or protecting against the COVID-19. Just like us also can be part of developing new materials. It is lighter, more durable materials which may have some surface reactive properties which make that they can actually communicate with us. It is also materials which are more biodegradable, meaning that we can develop, for example, bioplastics that will reduce the amount of plastic waste which is generated. In this way, we can also develop materials and production processes where we can reuse waste materials. And a very good example of that is all of the composite material waste which is generated from worn-out wind turbine mills. Engineers in chemistry and biotechnology is also involved in developing easy and accessible foods. try to look at this nice cupcake here. There's actually quite a lot of engineering that has went into this one in order for us to be able to buy it in the supermarkets. So we develop new food products. We are developing new formulas so we can extend the lifetime of the food products. In this way, we reduce the amount of food waste. We also develop new healthy substitute that make the food contain less sugar and less fat, and all in all that improves the human health. So this just shows that the application area of this education here is really, really broad. So there's a lot of different job opportunities after your education. You can go into development of new production processes. You can work with quality control. You can go into the research department of different companies. Also, quite many chemical engineers ends up as good managers because you get some good collaboration and managing skills during your education. You can also go into teaching. You can consult within work environment, or you can do general consultancy where you get to help other people and companies with a lot of different types of problems. Also, chemical engineers are very good entrepreneurs, so starting up own companies and exploring their own creativity. So there's so many opportunities out there. What skills do you then get from this education? Well, foremost, you become a problem solver. You get a deep understanding of theory, and then you also really get to try it out in practice, so you get a lot of practical application skills. We also teach you a structured approach to how to attack a problem, how to solve a complex challenge. And then as you are forced to work in groups, you also get very good collaboration skills, both for the people who knows what you're within your own field, but also people outside of your field. That also means you get good communication skills, because the projects you are going to work with during your education, you need to defend that at project exams, and these defenses, these exams are based on presentations. And all in all, that prepares you very well for the job life after your education. And to the right here, I just listed some names and some local Danish companies where we have provided candidates the last years, but there's just to provide examples, but there's so many more opportunities. To be a student at Aalborg University here at our campus in Esbjerg, you are centered in the midst of the three main areas of the university responsibilities. Of course, we do teaching on high excellent level. We also do research on high excellent level, and then we participate in external collaboration with companies, with funds, with national and international funding bodies. And as a student here, you will be involved in all three arms, so to speak, because the projects you're going to work on, they will be embedded within our external collaborations or our research, and this way they add into the teaching, making sure it's relevant problems you're working with. So what is problem-oriented project work? Well, it is students who form groups that on an entire semester collaborates on solving a problem for society in general or for a specific industry or company. So we make sure it's always relevant problems you're working with. And being a student here in Esbjerg, you have a nice photo of our campus down here. I'm sitting right here. Well, it's a smaller campus. Aalborg University is distributed on 3 different campuses inside the borders of Denmark, and Esbjerg is the one down here. But since it's a smaller campus, it also means that we have very good contact with our students and as researchers and teachers. So we know you don't get lost in the numbers here, and there is a quite good feeling of unity at campus between staff and students. And as an extra bonus info, there's around equal numbers of male and females on this particular education, which give a very good study environment. I've tried to put a few more words on what is actually a student project. Kasia here, she worked on her 3rd semester in a group who collaborated with a waste incineration plant L90 on trying to remove antimony and molybdenum, which they have problems with in their wastewater. So together with the company, they analyzed the pathways of these heavy metals from the waste during the incineration process, and then until it finally ended up in the wastewater. And then they analyzed the pathways, and then they suggested a possible solution to how to remove it in the wastewater treatment plant. Later on, this was also implemented by the incineration plant. Danny down here, he collaborated with LM Wind Power, who produce windmill blades, On his 6th semester, he was in company practice in the company, and then he later on did his bachelor thesis with them as well. And he studied the glue that they were using for the composites. He tested how it acted under different conditions. He got some data out of it. He made a model that could predict how it would behave, and then they could actually see how that influenced the blades. And then later on, he got employed in the company. He's actually still there. Linda, she was on company practice at Untitled Energy here in Esbjerg. So that is also an opportunity on the education. And during the internship, she worked with a group of engineers on designing a flare system to be used offshore. Gunhild, she used the opportunity to take a semester abroad, which is also a possibility. She went to Paris in France, where she got to use some very nice analytical methods for her material science project. She was working on developing some new medical devices. And also, she enjoyed the life in a large city very much. If we look at the more factual-based structure of the study, then this education here, it's a 3-year bachelor, chemical engineering and biotechnology. And you can see the structure layout here, the different courses and project modules over here. This bachelor here provides the foundation that you can afterwards specialize in either chemical engineering or our bioengineering master science. And there's some other presentation videos on them on the web page. If we take a closer look at the courses here, then each semester is structured equally with 3 5 ECTS courses and then a project module over here, which on the first semester is divided into 2. The courses, they provide you with the backbone skills, the theory in math and chemistry and biology, biotechnology, which you need to use in your projects in order to solve the problems. On the first semesters here, you get build on your high school levels, and then later on we bring in some more engineering courses where you get into chemical reaction engineering, heat dynamics, where it builds more on the physics, etc. In the projects over here, you then get to use half of the semester in order to apply the theories that you learn in the courses. And here you get to apply it on a real world problem. You get to analyze the problem, use the theory in order to test out your ideas practically in our lab. We have some very good lab facilities, and so that also makes this education here very dynamic, because it's a good mix between theory and learning theory-oriented activities, and then also practical skill sets to be learned in the lab in order to actually test out your ideas. Your day at the university is a mix between modern teaching and project work. Our teaching method is a mix between digital teaching and physical teaching, so you will be exposed to flipped classroom style teaching, where you get to see video and prepare at home, and then you can meet up at workshops and problem solving activities face to face with your teachers at the university. Or it can also be lectures, guest lectures, etc., directly at the campus. This schedule here is an example of how a semester can look like. This is taken from our 3rd semester on our education. And as you can see, all teaching activities is structured in half-day seminars, which can be a mix between these lectures, problem solving, workshops, etc. So we complete the activity within in the morning, and then you may have a new activity in the afternoon. All of the white dots here, it's not because you necessarily are free from the university. University is a full-time study, but that is where you're going to work with your projects in the group. And how to manage this time here in all of the white spots here, that is actually up to you. It's the group themselves who learn to manage their time productively and work and progress with their projects. And we'll teach you these project management skills, making time plans, resource plans, etc., etc. All in all, this provides a good amount of flexibility, but we also do have a clear expectation for you to be an active participant in this education here. If you're interested in more information, I recommend you to go to our university webpage, au.dk, and then under the Education and Programs, Bachelor Programs, you will find our webpage that introduces more the Chemical Engineering and Biotechnology Bachelor. Also, if you want to know more about our lab facilities and possibilities in student projects, then there's more to be seen in the presentation of the Master Educations in Chemical Engineering and Bioengineering also on this webpage. Hope to see you. Bye.